All right, 2.1 is dealing with relations and functions. And so there's a couple things just to start with as far as terminology goes to make sure that everybody is clear on. Okay, first of all, the term relation. Okay, relation is basically the mapping of input values with output values. And what this allows you to do here is it allows you to distinguish two terms that you're probably familiar with. The input values are simply the domain. The output values are referred to as the range of a relation. And domain is usually, in terms of x's and y's, the domain is usually the x, the range is usually the y values. And so when you're looking at an ordered pair, and so let's say I gave you a set of relations that looks like this. All right, so if I ask you what is the domain and range of this set of relations here? Okay, the way that you would do this is you simply look to see. The domain is all the x values, the range is all the y values, the inputs and the outputs. So if you go through and I ask you to identify the domain, I'm asking you to enter numbers from the least to greatest, separated by a comma with no spaces. So what would be the smallest input value in this set? So the domains are our first values. So what's the smallest of those numbers? Why? Okay, so -1. Do we have to, if we have an input, a repeated input, do we need to write it multiple times? Or just the one time? Just the once. Okay, so in this case, we have this repeated input of -1, but we just write it one time. Then what would be the next highest number? 0, and then the final one, 2. So this is how you would input, or this is how you would type in your domain for this. -1, 0, 2. That would be your domain. If we wanted to identify the range is going to be the y values, or the output values. So once again, it's the same idea. You start with the lowest number and then increase from there. So what's the lowest number in the range? We have 0, -3, 3, and 1. So -3 followed by 0 followed by 1, and then lastly 3. Okay. So when you're looking at these, the first part is just to be able to identify the domain and range. And now there's another more specific classification of relation, and that is a function. And a relation is a function if each individual input value has exactly one output. Okay, so in order for something to be a function, what that means is no matter what you put in as its input, if you enter a specific input, the output is always the same. It's never going to change. There's never going to be more than one output value for each input. So if we look at this problem right here and come back and look, is this a function? Okay, when we look at our inputs, so -1, if we look at -1, we get an output of 0. Is there any other input value that would yield a different outcome or an output other than 0? Yeah, what happens right here? So we look at this input of -1 also can output a 3. So when it's inconsistent in this way, If an input gives you different outputs, then it's not a function. So this would not be considered a function. And what if I took a similar set of relations here? Okay, so here, this set is pretty similar. If we look at these, and I wanted to determine, is this a function? Okay, when we have an input of -1, are there any other inputs of -1 that would yield something different than 0? No. What about 0? Any input of 0 that yields something different than -3? No. Any input of 1 that yields something different than -3? No. And finally, any input of 2 that yields something different than a 1? No. So this would be, yes, it is a function. It doesn't matter that two inputs have the same output. All that matters is that two inputs don't give you different outputs. The same input cannot give you different outputs. Right? So there's two ways to check to see if something is a function. The first is to just test the input and outputs and compare them. The second is what's called a vertical line test. Right? If you take a relation and you graph it, if there exists a vertical line that would pass through your graph in more than one place, then that equation or that relation would not be a function. So is there anywhere on this red graph that I could draw a vertical line that would pass through the graph in more than one place? No. No matter what, if I drew any vertical lines here, it would only pass through the graph at one place. So this would be considered a function. And what about something that looked like this? Parabola. Is there any place on this parabola that I could draw a vertical line that would pass through that parabola in more than one place? No. So it passes the vertical line test. It's also a function. And what if I took this graph? Is there any place on this graph that I could draw a vertical line that would pass through the graph in more than one place? Yeah, so this one is not considered a function. It doesn't pass the vertical line test. And in fact, if you look at this, if we chose this particular x value, we'd have an output that could be positive, but we could also have an output that would be negative. So you can see, or even when you connect it to the testing of inputs and outputs, that it would not be considered a function.